minus r less than or equal to a less than or equal to r. So when you have this statement, you can write it that way as minus cn less than or equal to up to an less than or equal to cn. So now we know that the cn goes to 0. It's telling us that if an is any sequence, and when we say any, we mean any. If an is any sequence, if limit of absolute value of an is 0, then limit of an itself must be 0. If limit of the absolute value of an without the absolute value must also be 0. And the proof, we use the sandwich theorem to prove it, which is below. So again, is the concept that we require. We shall apply it to evaluate some examples. So it's telling us that if limit of absolute value of an is equal to 0, then limit of the an must be 0. Okay. All right. So we have some few examples that we want to evaluate. And I would want to emphasize that from this stage, or at this stage, we shall be learning how to evaluate limit of sequences. When you are asked to show that, look at this statement. They say let an be equal to sine n over n squared. Show that the an goes to 0 as n goes to infinity. When there is no mention of epsilon n definition, please do not use that. The epsilon n definition is just to prove that something is limit of a certain sequence. Something is limit of a certain sequence. So under epsilon n definition, the limit will already be given to you. Then you will now prove that, oh, actually that is the limit of this sequence. So that is the essence or the purpose of the epsilon n definition. But when we come to evaluating or computing limits, your task would be just to find the limit. You have to find the limit. And you will find the limit by using any technique you know. Remember, the epsilon n definition, but you use it to prove that actually this is limit of that sequence. But the task we are, or where we are now, we are going to learn techniques of evaluating the limits. So we will start with just one of these examples and see what happens. I have an example, then we see what happens as we move on. We want to evaluate this simple limit. Let's go to the board, then try to do that. Over there, I want to take that. So example. The chance to ask for examples. So let's pick the. Let's look at this one. I'll give you a technique, or we'll start with some of the techniques. When you are asked to find limit of something as n goes to infinity, the first thing to do is try to substitute in place of n, put infinity. If it gives you a finite number, then that becomes the limit. If it is giving you an indeterminate form, it means you have to do something extra. If it is giving you infinity, it means the limit of the sequence does not exist. So I will start with the very simplest form. So let's take this one. If we were to evaluate limits of 1 over n as n goes to infinity, or if we were to find this limit, I'm starting with the very simplest form. So this one, the solution would have been that limit as n goes to infinity of 1 over n is equal to 1 over infinity. In place of the n, we put infinity. So when it gives us 1 over infinity, we know 1 over infinity is 0. Also, 1 over minus infinity is 0. 1 infinity is also 0. So this 0 becomes limit of the sequence. You are done. We are able to evaluate. So the first thing to do is to slot in infinity in place. If it gives just a finite number, that becomes your limit. So let's look at the second example. Second example, we want to goes to all over n squared plus 4. 3n squared plus n all over n squared plus 4. We want to evaluate the limit or compute the limit. And as I indicated, in computing limit, you are actually finding the limit. You are not using epsilon n definition. So this one, the